Hello, my name is Elliot Conlon, and I'm the president of the Wentworth Sounding Rocket Team. I'm a junior studying mechanical engineering with a minor in aerospace engineering. The 2024 Argonia Cup will be our first official entry into competition as a team. We will be flying a custom-built 4-inch to 4-inch two-stage rocket. Our rocket will be 13 feet tall as it sits on the pad, our sustainer being 9 feet tall and our booster being 4.
Hi, my name is David Billia. I'm the Vice President of Wentworth Sounding Rocket Team. I'm a junior in mechanical engineering with a minor in aerospace engineering and manufacturing. I'll mostly be talking about the avionics phase. We have two avionics bays, one in our sustainer and one in our booster. For our sustainer avionics bay, we're running a dual redundant system. Our primary electronics are an AIM Extra 4 for the primary charges and for tracking on 915 megahertz. Our redundant electronics are an RRC2 Plus from MissileWorks, running a 1-second delay. We also have 3 cameras, one looking up, one looking down, and one looking out. And for our booster avionics bay, we're running an Altus Mega for tracking and deployment on 400 megahertz.
Hi, my name is Sarthak Mandavia. I am the treasurer for the Wentworth Sounding Rocket Team. I'm a junior in mechanical engineering with a minor in aerospace engineering and business management. I'm going to be talking about the recovery of our sustainer and booster stages. For our sustainer, we're going to be running 2 chutes, a drogue and a main. Our drogue is going to deploy at apogee, while our main is going to deploy around 400 to 800 feet, depending on the wind and weather conditions on the day of launch. Our target descent rate for the drogue is going to be about 45 feet per second, with our main target descent rate being about 12 feet per second. Our drogue chute is a recon recovery Classic 2 20-inch chute, with our main being a recon recovery Cert 3 XL. Our booster stage is a single chute 24-inch recon recovery chute, with the target descent rate being 25 feet per second. All of the shock cords being used for recovery are 1/2-inch tubular Kevlar from 1 Bad Hop. Our recovery is being done with 4F black powder charges with 150% redundant backup charges to the corresponding main charges.
Hello, my name is Caden Reiner. I am a freshman here at Wentworth Institute of Technology. I am majoring in mechanical engineering and minoring in aerospace. Today I'm going to be going over the construction of our entry into the Argonia competition. We are using 4-inch Wildland airframe and nose cone for both our booster and sustainer, and mounted in within each is 54mm motor mounts. For our root bound, we are using Hysol E120 HP, and for our fillets, we are using West Systems 610. For our fin can, we're doing slide in with 3 fins each on the booster and sustainer, with through wall fins with 3/4 internal external fillets, and for motor retention, we are using 2 Aeropack retainers to keep in the motors in the booster and sustainer.
As for the motor choice for the 2024 Argonia Cup, initially we looked into doing an L2200 to D12, making it effectively a boosted dart while being compliant with the 2-stage requirement. This allowed us to get the max impulse allowed in the competition with the least amount of weight and sustainer. This motor setup reduced the dead weight and allows for more golf balls to be carried to apogee. We then looked into a more traditional 2-stage setup with about a 60-40 split between the booster and sustainer, and we landed on an L1000 to get us off the pad and a K250 to give us a long sustained burn time.
To decide on the size of airframe tube we were going to build our rocket around, we used several tools, including a Wolfram Alpha plugin for stacking spheres in a cylinder, modeling golf balls in CAD, testing real golf balls in actual tubing, and Excel spreadsheets to track the data and calculate the most efficient tube size.
The lowest number is 7.5 on 7.5-inch lock paper tubing that is unsleeved. For reasons of strength and structural integrity of the rocket, we decided to not go with paper tubing and decided to stick with fiberglass or carbon fiber from Wildman. We found that the next most efficient would be 5-inch Wildman tubing. We initially also looked at doing a max altitude attempt on a 2-inch diameter rocket. However, we decided against this as we very quickly found out that the scoring equation heavily favored bringing more golf balls to a lower altitude than bringing, say, 10 golf balls to 40,000 feet. We finally decided on approximately 140 golf balls in a 5-foot section of tubing at nose cone, as 4-inch Wildman tubing comes in a maximum length of 5 feet, and for structural reasons, we did not want to coupler tube together multiple payload sections.